First up, we have the vehicle cruise mode, in which the vehicle is able to move without any pedestrians in sight. Secondly, we have the case where there's no pedestrians, but there is a stop sign, or a road sign to be exact. The vehicle slows down and continues. Thirdly, we have a road sign, walking pedestrian, and a walking pedestrian, where the pedestrian crosses the road. The vehicle stops and gives way to the pedestrian. Next, we also have the stationary pedestrian scenario, where there's a pedestrian standing right beside the road. Next, we have a walking pedestrian case where the pedestrian is trying to cross the road. So he stands by the road and starts walking across it as the vehicle approaches. The vehicle senses the pedestrian, predicts his path based on LiDAR and RGBD camera inputs, and from there, it does some point clustering and is able to then predict the time to collision of the vehicle for the pedestrian before it slows down and gives way. This is another case of another walking pedestrian crossing the road. Similarly, the car slows down and gives way after it senses and predicts that the pedestrian's path will coincide with its own. It waits till the pedestrian is finished walking across the road before it continues. We also have another case where there's a pedestrian walking alongside a road, which is a common occurrence, in order to detect whether the car predicts that the pedestrian is trying to cross the road or not. In this case, pedestrian is clearly not trying to cross the road, and hence the vehicle similarly just slows down. And lastly, we have the case where we just have an autonomous Stanley controller test for the vehicle to navigate through a curved path. In this case, which is a loop that has been marked out on the ground, and we use the GNSS coordinates, which have already been pre-planned, and we follow it so that the vehicle is able to control itself and follow the loops